What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 5, Section 8, Modeling Using Variation. Let's do it. What is true of the appearance of graphs that reflect a direct variation between two variables? So again, direct variation is something like this, y equals k times x. And the nature of x can change as well. But the main thing is, this pretty much looks like a power function. We could also have it be x squared, x cubed, so on and so forth. So something along those lines, it will have an appearance similar to that of a power function. There's your answer. Boom, done. Is there a limit to the number of variables that can vary jointly? Explain. So again, joint variation, an example might be a constant times x times z, something like this. So the question is there a limit? Like right here, it's y varying jointly with two variables, x and z. And the answer is no. I could have w, t, what else? U, V, so on and so forth. I could go on and on. So there's no limit. That's the answer. So for this one, we're meant to create an equation based on this description. So it says y varies directly, which means it's y equals k times something, as the square of x, which means it's x squared. And then they give us one other plug-in point. They're saying when x is 4, y is 80. This is what's going to allow us to solve for k. So we're going to plug in 80, and we're simultaneously going to plug in 4 for x. So I have 80 equals k times 4 squared. 4 squared is 16. Then we're going to divide both sides by 16, and we get k equals 5, which means the final equation will be y equals, replacing k with 5, times that x squared. There's your answer, done. For this one, it says y varies directly as the cube of x. So y equals some constant times the cube of x, aka x cubed. And then to solve for k, we've got these two values. So I'm going to plug in 24 for y and 36 for x and solve for k. So 36 cubed is a huge number. It is 46,656. Use the calculator there. It's pretty gigantic. Then to isolate for k, we're going to divide both sides by 46656. And then when you divide the top and bottom by 24, this simplifies to k equaling 1 over 1944. So now we can rewrite this equation. We got y equals, and then I'm going to put in for k 1 over 1944, and then times that x cubed, and there's the answer. Boom, done. Y varies directly as the fourth power of x when x equals 1 and y equals 6. So the fourth power would mean directly is k times x to the fourth. And then to solve for k, we're going to plug in 6 for y and 1 for x. So now we have 6 equals k times 1 to the fourth power, which is just 1. Which means right off the bat, k equals 6. So if I'm going to rewrite this now, we'd say y equals 6 instead of k times x to the fourth. There's your equation, done. For this one, y varies inversely as the square of x. So what does that mean? When it's inverse, it's simply our k goes on top of whatever this is, the square of x, meaning x squared. So there's our baseline equation. Now we have to solve for k, and we can do so by plugging and chugging, plugging 3 in there and 2 in here. So we got 2 equals k over 3 squared. 3 squared is, of course, 9. So to solve for k, we multiply both sides by 9, and we get k equals 18. Now we can rewrite this original equation, plugging in 18 for k. So we get y equals 18 over x squared. There's your answer, done. So for this one, y varies inversely. Again, that means it's k over the x value as the fourth power of x. That's literally x to the fourth power. And now all we have to do is solve for k. So we're going to plug y in, 1 there, and that 3 in for x here. So we have 1 equals k over 3 to the fourth power. So what is 3 to the fourth power? 3 times 3 is 9, times 3 is 27, times another 3 is 81. So k over 81 equals 1. Multiply both sides by 81, k equals 81. Last but not least, let's rewrite this, plugging in 81 for k and leaving that x to the fourth. So there is your equation, done. So for this one, it says y varies inversely, meaning k is over the x variable, as the cube root of x. That's the cube root of x, like so. And then we have these two values. When x is 64, y is equal to 5. So we're going to plug those in and solve for k. So 5 equals k over the cube root of 64. So what is the cube root of 64? That's 4, because 4 times 4 times 4 is 64. So that's just 4. And then to solve for k, multiply both sides by 4, k equals 20. Last step, we're going to rewrite this equation with 20 subbed in for k, so it's 20 over the cube root of x. So there's your final answer. Done. Y varies jointly as x, z, and w. So what does that mean? Y varies jointly, so it means it's y equals k and then times each of these, x, z, and w. And now again, we're just trying to solve for k to get the final equation, and they give us values for x, for z, and for w, and for 100. So all we do is we just plug everything in. 100 equals k times 1 times 2 times 5. 1 times 2 times 5 is 10. Then we divide both sides by 10, and we get k equals, well, 100 divided by 10 is once again 10. Now we can rewrite this. Y varies jointly with k being replaced with 10 now. And then we have x, z, w. There's your equation. Done. For this one, it says y varies jointly as x and the square root of z. So y varies jointly, meaning y equals k times both of these, x and the square root of z, when x equals 2, z equals 25, and y equals 100. So now the last step is just to solve for k. So we're going to plug and chug. 100 equals k times x is 2, and z is 25. Square root of 25 is 5. 5 times 2 is 10. So we have 100 equals 10k. To solve for k, we divide by 10 like so, and k equals 10. Now I can rewrite this original equation by subbing 10 in for k, and we get y equals 10, and then we still got the x, we still got the square root of z, and there's your equation. Done. So for this one, again, it says y varies jointly with both of these, and then inversely with w. So let me show you how you pair all this together. So for the joint, that's basically like direct. So it's k with x and z. Now inverse, normally if we just had it alone with inverse, it'd just be y equals k over w. But it's that same principle when it's inversely varied, that w goes on the denominator. So here, instead of just k, we have k and x and z over w. So there's our nice baseline equation. Now we can solve for k by plugging in 3 here, 5 here, 6 here, and 10 here. So we got 10 equals k times 3 times 5. That's the x and the z over w, which is 6. So then we have 10 equals 15k over 6. Then I'm going to multiply both sides by 6. I get 60 equals 15k. Divide by 15, k equals 4. So now we're going to rewrite this as y equals 4, and then x, z over w. There's the equation. Boom, done. For this one, we have y varies jointly as x and z, and then inversely as the square root of w. So the way you want to think about it is for the joint, it's just typical direct variation, k times x and z. And then that inverse, normally it'd be y equals k over the square root of w. So here it's jointly and inversely. So then whatever is the inverse variation, that goes on the denominator. And they said the square root of w. So I'm just putting it as it's being described. And also the square of t. So we can also throw a t squared up here. It's inversely with the square root of w and the square, meaning t squared. Now we got to solve for k, so we're going to plug and chug. So we got 3 in for x, 1 in for z, 25 in for w, 2 in for t, so much stuff here. And then y for gets 6. So now we have 6 equals k times 3 times 1 over t squared, which is 2 squared, and then times the square root of 25, which is w. So then 6 equals 3k over 4 times square root of 25 is 5. 4 times 5 is 20. And then to isolate k, first we're going to multiply both sides by 20. 120 equals 3k. Then we're going to divide both sides by 3, and k equals 40. Now the last step, we're going to rewrite this, subbing in 40 for k. And you know what? I'm going to put 40 actually right in the front. Sort of this is how it's in the back of the book, but you could put it on the front or with the numerator. Both are correct. And then we've got x, z on top, and then on the bottom, we have that t squared, and then radical w, and there is your final answer. Done. So for this one, it says y varies directly as the square of x, meaning y equals a constant times x squared. Then it gives us this first value, x equals 2, and 16 equals y. The arrows should be pointing here. So we're going to run with this. We got 16 equals k times 2 squared. Why are we going to run with plugging this in? Because this is going to help us solve for k. So that's the first step. So we have 16 equals 2 squared is 4. And then we divide both sides by 4, and we get a value of k equals 4, right? 16 over 4 is 4. Now I can rewrite our equation. This direct variation is y equals 4x squared. And this is great because this is now going to allow me to answer this question. Find y when x equals 8. Because now I can take that 8 and I can plug it into our nice equation. And we get y equals 4 times 8 squared. 8 squared is 64. And then 4 times 64 is 256. So y equals 256. Boom, done. This one, it first says y varies directly, meaning just k times whatever this is, and it says the square root of x, so boom, there's our equation. Now it gives us these original values of x and y. That's going to help us solve for k, so let's start there. Plug 16 in here, plug 4 in here, and we get 4 equals k times the square root of 16, which is just 4. So since 4k equals 4, divide both sides by 4, and k equals 1. Which means that our equation is just y equals 1 times rad x, or just y equals rad x. Then we're going to plug 36 into this equation to solve for y. So y equals the square root of 36, just taking the positive square root, y equals 6, boom, done. This one that says y varies inversely with x, meaning it's k over x. That inversely means that x goes on the denominator. Then it says when x equals 3, y equals 2. That means we can solve for k. So let's multiply both sides by 3, and we get 6 equals k. And now we can rewrite this original equation. Y equals 6 over x, replacing k with 6. And then it says find y when x equals 1. So now in this equation, we plug and chug. We plug 1 in there, y equals 6 over 1, which means y simply equals 6. Boom, done. Y varies inversely with the cube of x. That means y equals k over, because of that inverse, right, over the cube of x, meaning x cubed. Then it says when x equals 3, y equals 1. We're going to plug those in so we can solve for k. 3 to the third power, or 3 cubed, is 27. Multiply both sides by 27, and that's what k equals. Now we're going to rewrite the original equation as y equals 27 over x cubed. Now we want to find y when x equals 1. So now we take that 1 and we plug it into this final equation. Y equals 27 over 1 cubed, which is just 1, which means y equals 27. Boom, done. Y varies inversely, meaning k over the cube root of x. Literally, just write the cube root of x. Now it says when x equals 27, y is 5. We're going to plug these in so we can solve for k. So let's evaluate. The cube root of 27 is 3. And then to isolate, we're going to multiply both sides by 3. So k equals 15. So now I can rewrite this equation with 15 plugged in for k. And then last but not least, it wants us to solve for y when x equals 125. So we're going to plug in like so. 15 over the cube root of 125. What is the cube root of 125? It's actually 5, because 5 times 5 times 5 is 125. So y equals 15 over 5, which means y equals 15 over 5 is 3. So y equals 3. Boom, done. So for this one, it says y varies jointly as x, z, and w. So that means y equals k times, it says jointly as all 3. So it's literally x, z, w. Now we're going to solve for k first. So it says when x equals 2, z equals 1, and w equals 12, then y equals 72. So that's enough information to plug in. So we get 2 times 1 times 12, which is 24. K equals 72. Then to solve, we divide both sides by 24, divide by 24, and I get k equals 3. So now I can rewrite this as y equals, replace k with 3, x, z, w. Now it says find y when x equals 1, z equals 2, and w equals 3. So let's plug and chug. 3 times 1 times 2 times 3, that's 6 times 3 is 18. So 18 is the answer for y. Done. For this question, it says y varies jointly as the square of x, that's literally x squared, and the square root of z. So that's just like direct variation, but with both of these things. So it's all one line. Then it says x equals 2, z equals 9, y equals 24. So we're going to plug those in so we can solve for k. So 24 equals k times 2 squared times the square root of z, which is 9. So 24 equals k times 4, and then square root of 9 is 3. And that's 12. So 12 times k equals 24. Divide both sides by 12, and k equals 2. That means we can rewrite the original equation, subbing in 2 for k, as 2x squared square root of z. Now we're trying to solve for y when x equals 3 and z equals 25. So let's plug and chug. Y equals 2 times 3 squared times the square root of 25. So square root of 25 is 5. 3 squared is 9. So it's 2 times 9 times 5. 2 times 9 is 18. Times 5 is 90. Y equals 90. Boom, done. Y varies jointly. Again, that's k, the square of x, that's x squared, and the cube of z, that's z cubed. And so now we talk about that inverse relationship with the square root of w. So inverse usually means k over that variable. So the piece with the inverse relationship is going to be on the bottom, the square root of w. Now we're going to solve for k by plugging in these values over here for x, z, w, and y. So y is 12 when x is 2, when z is also 2, then that's 2 cubed, right, over the square root of w, and w is 64. So now we're going to evaluate. 12 equals, and then on top we have 4 times 2 cubed is 8. So 4 times 8 is 32k over the square root of 64 is actually 8. 32 over 8 simplifies to 4, right? 32 divided by 8 is 4. And then last but not least, divide both sides by 4, and k equals 3. So now we can rewrite the main equation as 3x squared, right? Plugging in 3 for k, z cubed over the square root of w. Last but not least, we're going to solve for y when x equals 1, z equals 3, w equals 4. So let's plug and chug. So we got 1 in for x, we've got 3 in for z, and then we've got 4 in for w. So 1 squared is 1, 3 cubed is 27. So 3 times 1 times 27 is 81 over the square root of 4, which is 2. So the final answer is 81 halves. Boom, done. So for this one, we're going to start by piecing together the equation, and then we're going to graph it in Desmos. So it says y varies directly with the square of x, meaning x squared. And then to solve for that k value, we're going to plug in 2 for x and 3 for y. So we know that 3 equals k times 2 squared, right? 2 squared. 3 equals 2 squared is 4. Then we divide both sides by 4, and k equals 3/4. So we know our equation is replace k with 3/4 x squared, and now let's graph it. So here's the equation, y equals 3/4 x squared. It's that nice parabola. Boom, done. So for this one, it says y varies directly, again, k times the square root of x, and then it says, and when x equals this, y equals this. So we can plug these values in to solve for k. So we got 2 equals k times the square root of 36. Square root of 36 is 6. So 2 equals 6k. Divide by 6, divide by 6. K equals 2 over 6, which reduces to 1/3. So now we have our equation as y equals 1/3 radical x. And now we can graph it in Desmos. So here is the graph. It's a radical function with that 1/3 in the front. Boom, done. For this one, we're going to start with y varying inversely. So that means k is on top as the square of x, and they're just saying x squared. And then now to solve for k, we plug and chug, plug in 1 for x and 4 for y. So we got 4 equals k over 1 squared is just 1. Multiply both sides by 1, k equals 4. So now my final equation, subbing in 4 for k, y equals 4 over x squared. Now let's graph it in Desmos. So here's the graph of the function, 4 over x squared. Boom, done. So for this one, it's asking us to use Kepler's law for 47, but it's asking us to rely on what we get for 46 to solve 47. So we're going to start by setting up this equation. It says the square of time is directly proportionate, meaning k, times the cube of the mean distance, aka a cubed. So we're going to start with this, and then it says if we know that t is 1 for Earth, so 1 squared is just 1, then we know that the mean distance is 93. We can use this to solve for k. Now, I'm going to plug this in millions of miles, meaning I'm going to say 93 for a. This is a bit of an arbitrary decision, but this is what I believe the back of the book uses, so I'm going to use the same value here. So now we can solve for k, which by dividing by 93 to the third power is 1 over 93 cubed. I'm not going to evaluate that out. It's a big number. We can just leave it as is. So now I can rewrite the equation with k as 1 over 93 cubed and then times a to the third power. And now we can plug in this 142 million miles for Mars as 142, right? In millions of miles to solve for t. So now we have t squared equals 1 over 93 cubed times a cubed, which is 142 cubed. So now let's plug this into Desmos and let's solve for this. So then we get 142 cubed over 93 cubed, which is approximately 3.5597. We'll just say 3.56. And then to solve for t, we take the square root of both sides and we get 1.8867, which will round to 1.89. So t equals 1.89 years. Boom. Done. So for this one, we're going to start with this information because we need our answer to 48 to solve for 49. So let's start. It says the time squared varies directly, right? It says Kepler's law says the square of time, t squared, varies directly with the cube of a. So k times a cubed. And we can use this to now solve for k with this information. It says using Earth's distance of 150 million kilometers, and that's for 1 year. 1 squared is just 1 times k times, and we'll just keep it as 150. We'll keep it in millions of miles. That way we don't have to write out all the zeros. And then we divide both sides by this, and we see that k equals 1 over 150 cubed. So now if I want to rewrite this equation, I've got t squared equals 1 over 150 cubed times a cubed. And then we want to figure this out for Venus, the time it takes for Venus to orbit for this mean distance from the sun. So we're going to plug in 108 in for a cubed. And since it's out here multiplied by 1 over this, it's basically just going to go on the numerator, 108 cubed over 150 cubed. Let's see what that is in Desmos. And we get this nice value of 0.373. We'll round to the nearest hundredth, 0.37. And then last but not least, to solve for t, we have to take the square root of both sides, which I'll do in Desmos as well. And then now we get 0.61. So we'll say roughly 0.61 years. Boom. Done. For this question, it says the distance s that an object falls varies directly. So s equals k, varies directly with the square of time, t squared, of the fall. Now it says if an object falls 16 feet in 1 second, how long for it to fall 144? So we have some interesting information here. Distance is 16, which is s. We can plug in 16 for s. And then it says that that would take 1 second, so we can plug in 1 for t. 1 squared is just 1. So now I got a constant, and that's what we want. We want to solve for k first. So now I can rewrite this equation as s equals, replace 16 for k, t squared, and now we can answer this question. How long will it take to fall 144? 144 is the value for s. It's the distance, so we plug and chug like so. Divide both sides by 16, boom. 16 goes into 144 9 times. So since t squared equals 9, take the square root, and t ends up equaling 3, and that was in seconds. So 3 seconds is the answer. Boom, done. So this one says the rate of vibration of a string under constant tension varies inversely with the length of the string. So let's just call that y. Varies inversely, that means some constant over, and then the length of the string can be x. So then if it says if the string and length is what we've called x. So now it says the string is 24 inches long, that's our x, and vibrates 128 times per second, that's our y, right? So we said y is the vibration. So that's enough that we can plug in to solve for k. So we got 128 equals k over x is 24. So now to solve for k, we're going to multiply both sides by 24. Using a calculator, we get 3,072. So now I'm going to rewrite this equation as y equals 3,072, plugging in for k, over x. And now it says, what is the length, meaning we're solving for x, what is the length when it vibrates 64 times? So now I'm going to plug in 64 for y, and solve for x. So first I'm going to multiply both sides by x. That gives me 64x equals 3072, right? The x's cancel out here. Last but not least, we're going to divide by 64. 3072 divided by 64. Using a calculator, we get 48, and this is in inches. That's the unit for the length, so x equals 48 inches. Done. For this one, it says the weight of an object, we'll call that y, varies inversely. So again, that's going to be k over something, with the square of the distance from the center of the earth, which we'll call x. So y varies inversely. That means k over the square of the distance, meaning x squared. So there's our general equation. Then it says if a body weighs 50 pounds, that's y. So let's plug and chug, because we know we have to solve for k. When it is 3,960 miles from the center, that's our x value, so that goes on the denominator like so. What would it weigh if it were 3,970 miles from the Earth's center? So let's first solve for k. So k equals, multiply both sides by 3960 squared, and that's going to be 50 times 3960 squared. It's a huge number. So as we multiply this out with the calculator, we get 78408. 0, which is 784,080,000. So now as we rewrite the equation, we've got that in for k and still x squared. Now we got to solve for this value by plugging and chugging, right? If it were 3,970 miles, and again, distance is the x value. So it's y equals this over 3970 squared. We're going to plug it into Desmos to see. So here it is all plugged in, and we get 49.748, which will round up to 49.75. So y equals 49.75, and the unit is pounds. There's the answer. Done. So for this one, it says the current in a circuit, let's call that y, the current, varies inversely, so that's k over, varies inversely with its resistance measured in ohms. We can just say resistance. When the current is 40, that's something to plug in for y. The resistance is 10, so we know it's k over, and then r we can plug in for 10. And this allows us to solve for k by multiplying both sides by 10, and we get k equals 400. So now we have this nice equation, y equals replacing k with 400 over r. And now it says find the current, which is y, when the resistance is 12. So we plug and chug like so. And then we got 400 divided by 12 for the answer. So let's do that in Desmos. So we get 33.3 repeating, which if we round to the nearest hundredth would be 33.33. And current is measured, what did it say, in amperes? So we say 33.33 amperes. There's the answer. Done. For this question, it says a horsepower that a shaft can safely transmit, and we'll call that y, varies jointly, so that's k times speed. Let's call that x. I would say s, but s is kind of look like 5 sometimes, and the cube of the diameter. So let's just say diameter for d, and that's going to be cubed. Now, our first objective is to solve for k, and look at this. It says the shaft of a certain material, 3 inches in diameter, so we plug in 3 for d, can transmit 45 horsepower, so that's 45, and then at 100 revolutions per minute, that's the speed, that's x. So you see, we just plugged everything in. Now we can solve for k. So 45 equals 3 cubed is 27 times 100 is 2700. And then to solve for k, we divide by 2700. And 45 over 2700 reduces to 1 over 60. So now we can rewrite the original equation as y equals 1 over 60 times x d cubed. And then now it says, what must the diameter be? We're solving for d in order to transmit 60 horsepower, that's y, and 150 for RPM, that's x. So let's plug and chug. We got 60 equals 1 over 60 times x, which is 150, and then times the diameter cubed. So now we're going to isolate. Let's first multiply 60 times both sides. So we get 3,600. That kills the 1 over 60, right? 60 times its reciprocal just goes to 1, equals 150 d cubed. Then we're going to divide both sides by 150, and that would give us d cubed equals 24. And then to solve for this, we got to take the cubic root of both sides. So we're going to do that in Desmos. And you can represent a cubic root by raising something to the 1/3 power as well. So that's what I did here. 24 to the 1/3 power is 2.88. So the diameter will be approximately 2.88 inches is the unit. Boom. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.